professional memberships in FIE, MISTE, building committee member, government body member of Vasu Engineering College, member of Academic Council of Sri Vasu Engineering College, Adipal Gudam. He guided two research scholars. Number of MTechs he guided 12, and is now guiding one research scholar, and number of MTechs guiding one. He published around 2 books, textbook on terrain evolution and earthquake response of structures, and another book, Proceeding of National Seminar on Corrosion in Concrete Structures. His publications, in number of publications, all international level conferences 20, at national level conferences 24, invited guest lectures delivered 26, number of short-term courses and seminars 25. His expertise is in consultancy services also. Now I welcome SRK Reddy to deliver his lecture.
Please give me permission to share my PPT.
Yes, sir. Sir, మీ వాయిస్ కొంచెం లో వస్తుంది సార్, కొంచెం మాట్లాడండి సార్ ఒకసారి. స్పీకర్ టెస్ట్.
ఓకే, ప్లీజ్
కొంచెం లో వస్తుందండి.
ఓకే, ప్లీజ్ గివ్ పర్మిషన్ టు షేర్ మై PPT.
Yes, sir. We have done, sir, already. Yes, sir.
Okay. Is it visible?
Yes, sir. Yes, sir.
Okay, thank you. So, respected Badam Sundarrao garu, Chairman ACC Kakinada chapter, and respected Durga Prasad, Secretary of ACC, and other members of ACC, and my colleagues of Godavala Engineering College, and other participants from other colleges and my student friends. Good morning to you all. So today, my topic is in fact response of structures considering soil structure interaction effects. As Sundarrao garu rightly pointed out, generally they carry out analysis assuming the structure is fixed to the base, and they calculate the loads and then design the foundation. They also consider the load combinations also. For example, dead load, live load combination, dead load, live load plus wind load combination, or dead load, live load, earthquake combination like that. But they are not considering the interaction effect of the soil and the structure, which is very important. In fact, so many changes will take place in shears and displacements in particular when you consider interaction, particularly for important structures and when rigid structures resting on loose soils. And IS 1893 recent code also, they have provided a clause that designers should consider soil structure interaction effect also when the structure is a very important structure and when the soil is loose. So with this small introduction, I go to my topic now. My topic is divided into 2 parts. First, I talk about general perception on natural hazards, because the soil structure interaction, that effect is more in case of lateral loads, earthquake, tsunami, wind like that. Therefore, just I would like to highlight the general perception on natural hazards. Second topic, of course, soil structure interaction. In that also, I take up what are the general failures that happened or that will happen for not considering SSI effects. And I also explain a case study how a response of typical structures can be obtained using or considering SSI effects. So general perception on natural hazards. All of you know that planet Earth consists of land, water, and air, providing cradle for existence of life. Without these three things, there is no life also, no plant or no life. Sometimes it causes disturbance in the form of earthquakes, floods, and windstorms, resulting large scale of loss in life and property. That's what we are looking in the recent years also, particularly floods, earthquakes, windstorms. And earthquakes occur sudden, and bulk of destruction takes place during short duration of time. In fact, tsunamis, floods, they give sufficient warning. But earthquake, all of a sudden it comes and a lot of destruction will take place. And occurrence of these earthquakes has become fast recurring phenomena throughout the world. And recent investigations say that in future also these natural hazards will increase in future. I will explain the reason for that also in coming slides. For example, recent Haiti earthquake, Chile earthquake, Japan earthquake 2011, even Gujarat in India. So these are the examples that in future many more natural hazards will occur. And unfortunately, most of the loss of life and property during an earthquake comes from total or partial collapse of man-made structures only. Unfortunately, in India, I can say, not much awareness has been created in the minds of people. I'm not talking about designers or structural engineers, minds of people, the importance of constructing earthquake-resistant structures and their response under different soil conditions. And therefore, awareness is to be created on the mechanism of earthquakes and tsunamis first, and also their effects considering soil structural interaction effect, so that the community living in earthquake-prone regions, coastal regions, they become alert and preparedness against such disasters. Now, you can see just at a glance, what are the natural disasters? Earthquakes, you can see during earthquake, some buildings may collapse also, and tornadoes, cyclones, and floods, fire. In Australia, on one side there will be fire in forest, on the other side there are floods. Similarly, volcanoes, because of earthquake, volcanoes will also erupt, and landslides we are seeing the Himalaya region, even at Durga temple of near Vijayawada, like that, and coastal storms, tsunamis, and hurricanes. All these are natural hazards which are to come in coming future also. Now, coming to the statistical data, you can see loss of human life in disasters. Earthquakes almost 55%. Of course, next flood 30%, and maybe other hurricane and others you can see. Therefore, important structures, particularly in earthquake regions. Our region, for example, our AP, Andhra Pradesh, from Visakhapatnam to even up to Nellore, it is almost in seismic zone 3. Therefore, special structures and important structures, considering soil effects, we have to design for earthquake effects also. And the number of disasters up to 2017, for the past almost 20 years, you can see flood, almost 43.4%, and earthquakes 7.8%, and of course storms 20, like that. These are the statistical data. Similarly, number of people affected during last 20 years. So most of the people affected due to drought, 45%, and earthquakes and other things, of course, 3% only. So these are the statistical data regarding the people affected. Number of deaths during last one. So again, 56% because of floods and storm, cyclones, landslides also. Right. Now, disasters disrupt the progress and destroy the heart and fruits of painstaking development efforts. In fact, we take lot of pains to develop our country. But at the same time, these natural hazards sometimes they disrupt and pushing the states and nations back by several years. If a dam will collapse, you can imagine how many years we go back. Therefore, this is construction of important structures against natural hazards is very, very important. Civilization exists and prospered mainly along the coastal regions as well as the river valley systems. These two are vulnerable for occurrence of natural disasters. If you look at the general scenario, California or Alaska, Tokyo, China and eastern part, or India also along the coastline, most of the natural disasters happen in valley areas and coastal areas. Therefore, majority of the world population also live on coastal regions, and is true in case of India also, because we have a lot of coastal region. So India is vulnerable for increasing phenomena of natural hazards in future, and particularly cyclones, earthquakes, and tsunamis. This was well proved by so many scientists. Coming to the disaster-prone areas, 58.6% almost earthquake region coming to India, and 12% flood zone, 68% drought, of course. And the total coastline of Indian subcontinent itself is 7,520 kilometers, and east coast belt itself is 3,480, and for entire AP state has a good coastline 974, which will be affected due to the storms and cyclones. Now, recent occurrences of these hazards along east coast reveal the importance of in-depth research in the following areas. Now, I request particularly the MTech students, even other participants, to note down these areas in which we have to work out. State of art of disasters and mitigation methods. That means first we have to understand how the disasters will come and what type of disasters and how to mitigate them. Then remote sensing and JS application. This is also very important. In fact, at the Gottawallar Engineering College, we have established a well center, water, environment and land center, wherein we have developed so many maps, soil map, transport, about 20 maps for Krishna district, and we are continuing for other districts of the state also. And it was well appreciated by a number of committees. And hazard resistant constructions against earthquakes, tsunamis, cyclones, floods, etc. That means we have to design the structures as hazard resistant constructions. Next, another important point is review of IS code provisions. IS codes, previous IS codes may not be, now they are not valid. Excuse me. The structures which were constructed 40 years back, now they will not satisfy as per the present IS codes. Therefore, sometimes they need retrofitting or repair measures. That is also one of the important topics of civil engineers. Now, new materials and construction techniques are coming. and where 3000 degrees temperature, setting temperature, and inner core is about 25 degrees centigrade temperature. Am I audible, please?
Yes, sir. Audible, sir. Audible, sir.
Sir. Outer core about 25 degrees centigrade, mantle 29 kilometer thick, 2000. All the and land, this is the 5 to 40 kilometer thick, and about our general temperature, surface temperature 25 or 30 degrees, and weight of earth is 5.5 into 10 to the power of 11 tons with an average specific gravity about 5.5. Just 1 minute, please. Excuse me. Core. Next, this is outer core, this is mantle. So this is only crust part. And all of it, the diameter of Earth is about 12,000, 740 kilometers. And it's because it is revolving, the equator is expanding, and whereas north to south pole, there it is decreasing, making a sea rise. All of you know, sea levels are rising. So this plate tectonic explains several aspects of earthquake South African plate like that. And you can see, suppose earthquake comes about 30 kilometers below the earth surface, for example, that is known as focus. So from this, the earthquake waves travel below the surface. When they reach the surface, then they transform into shear and rayleigh waves, and they make the structure to vibrate. So this is in fact, how waves radiate. And coming to the classification, the intensity of earthquake depends upon the focal depth, as I told you, magnitude. Magnitude is also very important. All of you know, in Kashmir, 6 magnitude earthquake, that means that is in terms of magnitude. And based on the source also. Now, during earthquake, what happens? The structure may slide. That there are failure modes. The structure may slide. And this is rocking effect. Rocking means to and fro movement only. Right? That means it may separate from the foundation or from a particular element. Next, bending. Bending means it is fixed, but the element will bend. Now, coming to what are the structural elements that will resist the lateral force, earthquake force means directly either roof, that is sloped roof, or RC slab. So they are the resisting elements. And shear wall. Shear walls are also resisting, and foundation is also a resisting element. So like that, only these elements will resist more when compared to other column or beam or like that, other elements. And what is the philosophy of design, earthquake resistant design? So any designer, he should keep in mind that so in case of minor earthquake, suppose if it is in zone 4, for example, then we have to design such that only non-structural elements may be permitted to get some damage, but structural elements should not damage. Similarly, for moderate earthquake, some structural elements can also damage, that means can beam like that, but without failure. And for severe earthquakes, it should give sufficient warning before failure. This is the in fact philosophy. And coming to the earthquake size, slight means up to 4.9. We got many earthquakes in India also less than 4.9. Every year we are getting, in fact. Moderate earthquakes 5 to 6.9. Great earthquakes. In India, we got almost more than 30 times great earthquakes. Assam earthquake, Bhuj earthquake, like that. And very great earthquake, 8.0. Even Bhuj earthquake also, very great earthquake. I will show you the particulars of these values also. And all of you know what are the codes available for seismicity. IS 1893 2016, 4 parts, all of you know. And 4326, that is resistant design and construction building. 13827, that is also improving earthquake resistant for masonry buildings. 13920, very, very important code, which will explain on ductile detailing of reinforced concrete structures. And 13935, again guidance for repair and strengthening measures against earthquakes. In fact, our research center, we have prepared the Amaravati area, where there is a possibility of earthquakes, but not much. These are the already occurred earthquakes every year. So maximum is only 5 to 5.9, that green, right? Therefore, moderate earthquake may come there. Of course, this is every designer should follow the seismic zoning map of India, and this is our most parts of our state. It comes under zone 3, and you can see Himalaya region completely zone 5 or 4. Now, another important point, particularly for lateral load and earthquakes, don't construct a structure like this, right? You can construct a structure with reducing the areas from bottom to top, but not like this. And similarly, this is also not correct, because all of a sudden we are decreasing. But which is right? You can see, you can separate a joint and make them symmetrical structures. You can see the difference between these two. So a joint is provided between these two blocks and another joint here. Similarly here also. So this is subjective to torsion, because it's in plan it is not symmetrical. You provide a joint here, then there are two separate buildings. So during earthquakes, you have to take care of regarding planning structures also. Same thing, keeping too much of overhanging portion, and again lengthy balconies. So this type of configuration should be avoided. Right, now I have come to the real our topic, soil structure interaction. I divide this topic into two parts. Structural failures for not considering effects. I will show you some pictures only. Then I explain a case study on response of considering SSA effects, and how to design a structure considering SSA effect also. In that case study, I will explain. Dear friends, is the slide visible, please? Yeah. Hello?
Yes, sir.
Visible, sir. Visible, sir.
Okay, thank you, thank you. Now, coming to the what is the difference between structural engineer and geotechnical engineer? In fact, engineer Sundarragar rightly pointed out how to join these two persons. That is very important. Structural engineer only he is concerned. He thinks that he is concerned only about structural configuration, allowable bearing capacity, and the generic nature, and then he will design foundation. That's all. Whereas geotechnical engineer, he will focus on inherent soil characteristics like C value, I value, NC, the bearing capacity factors, NC, NQ, and gamma, and eccentricity, CC value, shear modulus, density, these factors only. And they recommend the type of foundation, like whether it is isolated footing, raft, or pile, like that. So, what is the confluence between these two? Therefore, in fact, the dynamic interrelation where the response of soil influences the motion of structure. Please, I request all of you, please concentrate on the statement. Relationship where the response of soil influences the structure, and the response of the structure will also influence the motion of the soil, which is called soil structure interaction. Therefore, the response and influences of the soil and structure, they are interrelated. So they should travel in one cycle only. Right. Under static and dynamic loading, the foundation and the structure behave tandem. They should go together. Soil stiffness influences the effect of bending moment and also shears. If you don't consider the soil structure interaction, lot of differences will take place in bending moment and shear force values also in the structural elements. With huge mass and stiffness of structure, the fundamental time period of fixed base structure is very less compared to the time period obtained when soil structure interaction effect is considered. Very, very important point. When you consider the effect of soil structure interaction, the time of the structure increases. When the time period increases, then your base shears will increase. When your base shears increase, your design will aspects will change. So I will show through an example also. And it is well noticed that considering soil as a different elastic medium, the stiffness of soil gets normally designers, they design assuming the structure is fixed to the base. That means very stiff soil, assuming. But when the soil is very loose soil, totally the parameters will differ. Also, the amplitude, the displacement of structure, structural response is affected by additional energy dissipation induced in the system. Another important point is we assume that structure damping is only 5% approximately. When you consider soil structure interaction, soil damping is more, almost 10 to 15% depending upon the type of the soil. Therefore, these displacements will also vary depending upon the type of the soil, the damping factors of the soil. So the term free field motion denotes the motion that would occur the soil or rock in the absence of structure or any excavation. That means, suppose there is no structure. When earthquake comes, there will be some displacement of the ground itself. That is called free field motion. That also you have to consider when structure is constructed. Ground motion frequency content is strongly dependent on specific factors of earthquake and the site, and particularly the magnitude and epicentral distance on this site. As I told you, depending upon the zone where you would like to construct an important building, you have to consider those aspects also. That means zone factor, then importance factor. There are so many factors which are available in IS 1893 code. And this is, of course, also very important point. If you take a brittle material, for example, concrete or brick, you can see the stress curve, elongation. So almost even the apply some load, the elongation is very small and it is failed at lower elongation lengths only. Therefore, brittle material will not hold good during earthquakes. And when you consider ductile material, you can see even for small loads, it can elongate. And failure occurs only after it takes a certain elongation. Therefore, you should make the structure ductile. That is very important factor when you design a structure against earthquake loads. And IS 13920 code has given complete details how to make a structure ductile. And this is another important point. Normally, many apartment buildings, they will have open story, car parking, right? Therefore, the stiffness is only because of columns only. No shear walls and no walls. Almost it entire the 5-story or 6-story apartment building will be standing on columns only in the open story, in the car parking. Therefore, stiffness is very less. Whereas in upper stories, because of walls and other things, the stiffness is more. What will happen during lateral loads or earthquake or wind? You can see the displacement at ground floor itself is more. And therefore, there is a possibility of failure. Whereas the bare frame means when you introduce some retrofitting measures like introducing shear walls, bracings between the columns, then displacements are less. So this is also very important when you design, particularly buildings with car parking. So normally, high frequencies of about hazards, 10 cycles per second, dominant at rock and stiff sites. I am giving a rough idea. In case of rocky soil or stiff soils, the frequency is about 10 hazards. It's more. In case of it is less than 5 cycles per second. The behavior of foundation and soil is modeled by foundation impedances, generally in the form of soil springs. This is very important for analysis, which describes the force displacement and the radiation damping characteristics of the soil also. That means soil will be represented in case of springs in horizontal direction, vertical direction, and also it's in rocking mode and torsion mode. Rocking and torsion mode means, suppose the plan of the building is eccentric, C-shape or T-shape building, then torsion will come into picture. When the mass of the structure is not coinciding with the center of the stiffness, then torsional effects will be there. Therefore, we introduce torsional spring, rocking spring, vertical spring, horizontal spring. But normally for symmetrical structures, you can ignore torsion. And also ignore to some extent vertical direction also. The reason is you are already planning for vertical loads. Earthquake or wind. Therefore, horizontal spring and rocking springs are very, very predominant for when you consider soil structure interaction. I request the participants, if any questions are there, you can ask me at the end, please. Next, the structure is modeled by lumped mass system. That is a normal mode of the analysis. We lump all the total mass at one floor level and all the stiffnesses, columns, walls, everything in one floor only. That is what is called lumped mass system. Distributed stiffness models representing dynamic response characteristics. Now, buildings with and without cellar floors, I have already explained this point. Without and cellar floors, when subject to earthquakes, behave differently. The buildings with the cellars are more critical. Yeah, the displacement at level of ground floor itself is very high, as I told you earlier through picture. Now, this is a very important figure. I would like to explain. This is, of course, single. Let us assume it is a single degree. For example, water tank, right? So this is the water tank, and these are the columns, which will be considered as height h. Now you can imagine, I have introduced now, normally tanks will be designed only for stiffness, structure stiffness and mass, that's all. When I consider soil now, look at here, this is horizontal spring of the soil. Then this is rocking spring, rotational spring, K theta. And this is Kj means in a U direction, of course. This is horizontal spring. Vertical, I am neglecting. Now, what will happen? This is the modeling of a single degree freedom system, right? For horizontal and rocking only. Now, coming here, already due to earthquake, ground will displace. This is UG, is a ground displacement. We will not bother, right? Then this UF is because of earthquake, so the displacement can be observed through this spring, that is UF. So at this mass level, the displacement is horizontal displacement is UF, and due to rocking, that means when it vibrates like this, so theta into height, is it not? The displacement at the top becomes height into theta, therefore h into theta. That is the displacement due to rocking. And this is actually displacement due to the mass, right? That is due to mass and stiffness. Therefore, all these three put together, we get the total displacement. But unfortunately, if you don't consider the soil sludge interaction, we are designing the water tanks only for U factor, which is not correct. Because normally sometimes UF plus this S theta will be much more greater than U itself. I will show you through the case study. So this is the, in fact, the explanation for single degree freedom system. That means displacements may occur because of horizontal spring, because of rocking spring, and also the structure. Of course, I have neglected vertical and also torsion, because water tank normally no eccentricity. Therefore, and we design for vertical loads. So I have neglected vertical spring action and also torsional action. Right. Now, coming to this is not the summary of my topic. This is summary of soil structure interaction only. Next, I will take up the case study. Therefore, soil structure interaction SSI is not significant for cases of flexible structures resting on stiff soils. This is what IS code also says. Suppose structure and standing on stiff soil rock, then you need not consider soil interaction effect because that effect is very, very small. But SSI can be quite significant for stiff structures founding on soft soils, very important. Very stiff structure founding on flexible soils, lot of displacements will occur, lot of shear will occur. Therefore, very important point is if your structure is very stiff and your soil is very flexible or loose, you have to consider soil structure interaction effect also. Fundamental time period of soil structure system is much more longer than fixed base structure. All of you know what is the fundamental time period. The frequency omega is the root k by m, right? And if you divide by 2 pi, you will get the so in cycles per second. And 1 by f is the time period. I will show you a small example later. So this fundamental time period will be very longer when compared to a fixed base structure. And same thing in case of damping also. Damping of soil structure system is higher than damping of structure alone because soil damping is more than structure damping. And the total displacements can be increased by SSI. I told you just now. Therefore, when you consider SSI effect, the displacements will also increase considerably. And neglecting SSI effect is equivalent to assuming structure is supported on rigid material. And this is very important. All the designers should observe, and also, of course, MTech students and research scholars. IS 1893-2015, Part 1 clearly specifies that important structures and structures resting on flexible soils, soil structure interaction effect shall be considered while performing dynamic analysis. Now, I will show you some structure failure for not considering SSI effects, only for information only. Very quickly, I will go through. Normally, there are two types of damage. Tectonic surface process, that means totally earth will have a rupture. That is called fault rupture. Many examples are there. And next is regional subsidence and uplifting. In fact, when 2001 Indonesia earthquake occurred, 2004 Indonesia earthquake, the Andaman and Nicobar Islands totally twisted. The western part of Andaman and
అయిపోయినట్టు కొంచెం చూడవా సార్ వాయిస్
సార్ Dr. Reddy garu, your voice is not coming, sir.
The voice is not audible, sir.
అది ఎక్కడ ఫాల్ట్ మీ దగ్గర అండి
ఇప్పుడు వస్తుంది సార్.
Now okay, sir. Now okay, sir.
Now okay, sir.
ఓకే థ్యాంక్ యూ నౌ am I audible please? Hello, am I audible?
Yes, sir. It is audible, sir. Audible.
Okay, thank you. Sorry for the disruption. Now, our secondary effects are liquefaction. As I told you, I will show some figures also. And slow failures, we are observing landslides and tsunamis and sites, fire. These are all the secondary effects. So you can see this is the surface fault rupture, a bridge, a very big pier, how it has given crack. It happened in Taiwan earthquake. Now this in India, Ahmedabad Bhuj earthquake, you can see the entire apartment building has on ground, only lift portion, which was hardcore, it remained. So this is because of soil structure interaction effect. You can see one part has gone down here because of the settlement of soil, this pier. This is another example of elevated water tank. Because of settlement of soil, you can see how failure has occurred. During earthquake, of course. This is another interesting liquefaction effect. One story is completely gone down into the soil. There are so many cases happened in AP also. Probably you must be knowing in Hyderabad, one building totally it has gone. One floor has gone into the underground because of loose soil. That also will explain. Same thing. Water tank is falling down. If it is a 5-story RC framed building at Bhuj in India, sustained collapse of the upper story, but water tank has collapsed. This is another very important. You can see vertical split of partial collapse of 5-story RC building. It is a 5-story RC building, but you are probably seeing only 4 stories, and the cellar floor has gone down. It's because of settlement of soil. This will normally happen in case of loose soils. Therefore, soil testing, soil profile is very, very important before constructing any structure. So, during the settlement, what will happen to the columns, particularly in cellar columns? If one tie breaks down, what will happen? The spacing between other 2 ties will be doubled. When it doubles, it cannot take shear. Therefore, these vertical bars or longitudinal bars will buckle. So when they buckle, what will happen? There will be spalling of concrete. Therefore, then the structure will fail, column will fail. You can see how the longitudinal bars buckled because of shear. Therefore, during in earthquake-prone regions, particularly in ground floor, cellar floors, you have to place the ties or stirrups very closely. IS code says minimum 10 centimeters, in fact, 10 centimeters center to center. So this is, as I told you, during 2004 Indonesia earthquake, the Andaman and Nicobar, on one side, it uplifted. This is uplifted part. On the other side, it is subsidence. This is 2005 Kashmir earthquake. You can see how roadways are blocked completely because of sliding, collapse of the landsliding. Similarly, pipelines are also very important. Unfortunately, our people, they will not take much care and jointing. You can see. So what will happen when joint fails, particularly gas pipelines, ONGC pipelines, very, very important this aspect, design of joints. And this displays not only horizontally, but also vertically, and failed also during earthquake. This is a liquefaction. ONGC pipeline totally liquefied along the length of the pipeline. Now this is a very interesting photograph. 1964 Nagata earthquake. You can see due to liquefaction, almost some buildings were tilted, and this is almost totally tilted. But some buildings are intact because they are constructed. They were constructed on stiff soils. So this figure shows about the liquefaction effect. This is also settlement of and tilting of a building in Nagata again during 64 earthquake. So only for just understanding sake, I showed you some failure modes. Now, dear friends, a case study will be explained now on responsive structures considering SSI effect. Shall I take another half an hour, please? Okay?
Yes, sir. Sure, sir. Sure, sir.
Okay, thank you, thank you. Now, because now smart cities are coming and the number of districts have been increased each district, now they are made some capitals also. Therefore, major metropolitan cities in the world, not only in India, have registered enormous growth in population, resulting major construction activity. Right, particularly Hyderabad, Vijayawada, even at Kakinada. Kakinada is now made as a smart city. Therefore, unfortunately, in developing countries, not much awareness has been created in the minds of people about the importance of constructing earthquake or tsunami resistant structures, right? And the effect of soil structure interaction also. The main objective of this study is to ascertain various aspects of terrain associated with urban environment and to consider these aspects in dynamic analysis. I would like to tell you an important point. When you consider soil structure interaction effect also, some other parameters also you have to take into account because they are nothing but terrain evaluation, that area, and what is the type of soil, right? Therefore, that is also very important when you consider soil structure interaction effect. So in the present study, the terrain evaluation of high-tech city area of Hyderabad, in fact, I myself did this case study. In fact, that is my thesis problem also. I have taken very important area, high-tech city area, which is up and down hilly area in Hyderabad. So that I have taken. And for your kind information, during 20th century, now we are of course 22nd, almost 2 years past, earthquakes occurred 1300 and total number of deaths due to earthquakes 1.5 billion. Mostly in China, America, and India, and of course Japan and Indonesia like that. World population 6 billion by 2000, 7.5 we have already reached, and we are expecting 9 billion by 2030. Therefore, population is being increased worldwide. Urbanization continues apace, and hence the potential for damage due to massive earthquakes increases. In fact, in 1999, there are only 90 super cities. Super city means when the population is more than 2 million. Now, today in the world, there are more than 160 super cities. That means, and out of which 70% are in seismic zone, unfortunately. Therefore, the main seismic belts that trim the Pacific belt, I told you, and cross Southern Asia, Middle East area, Himalaya region, Turkey, and all the things, they are very much prone to earthquakes. It is felt that the interrelation between earthquake or tsunami, urban environment, soil structure interaction, and damage of structures. These parameters are very important for obtaining the seismic response and terrain evaluation. Therefore, I have taken the Hyderabad city as my study area because it is very undulating topography. I will go quickly. So these are the very important earthquakes occurred globally. And in fact, coming to India also, 7.9 earthquake, Assam earthquake like that. India, 1893 also it happened. Death toll also, in those days, 180 people died in India. And during Assam earthquake also more than 50,000. And even recent 2001 Gujarat earthquake, 40,000 people died. So these are the, of course, this I have already showed the seismic zoning map we have to follow. Now this is the location we have followed. So of course India, and when I did my research, it was a combined state of AP, And this is the, in fact, Hyderabad city. And again, this is in Hyderabad city. I have taken a small area that is Jubilee Hills. All of you must be knowing Banjara and Jubilee Hills area. This is Hussain Sagar, right? And this study area is exposed to many minor tremors up to magnitude 4 because Hyderabad is only zone 2. So maximum magnitude occurred up to 5 only so far. But unfortunately, in the case of moderate earthquake, suppose if the magnitude 6 comes, I'm sorry to state that many structures which are not designed for earthquake may get damaged. And Hyderabad city or any other city in India, as a matter of fact, can no longer afford to face such earthquakes. This is very, very important note, please. So why terrain evaluation is necessary? The investigator has chosen this region as case study not to create any panic to the public, but to create awareness among the builders, planners, and also administrators, particularly for Hyderabad people. And now, of course, for Visakhapatnam, Vijayawada, and other regions also. The study area is, and its involves represent an undulating topography with contours ranging from 488 meters to 637 meters. So you see the difference. And there are so many slopes southeast direction. The terrain is with typical topographical features like mountains, valley fills are there, slopes, pediments are there, on which many buildings were constructed, unfortunately. When I made some GIS survey, GIS application in Banjara Hills and Jubilee Hills, many buildings were constructed on loose soils. They were not knowing that below the structure, at say for example 30 meters below or 40 meters below, there were some streams were going. So therefore, the soil profile and the level of water table in this region are different in different landforms. Water table is also very important. Water table differs from place to place depending upon the soil conditions. And Latur, which is in Maharashtra but nearer to Hyderabad, once considered as a non-seismic area, in 1998, a great earthquake has come. Therefore, we cannot say in coming future, no earthquake, it is a non-seismic region. Therefore, soil structure interaction under the influence of different terrain features play a very important and vital role in finding out the dynamic response of any structure. Valley fills, very important point please. Valley fills form over a long period and appear to be consolidated on the surface, leaving loose soil underneath. Therefore, recent earthquake caused huge disasters to such type of structures constructed on such soils. So types of soils, of course, just I will skip this. We have identified the landform, that means where valleys are there, where ridges are there, hill slopes are there. Lithology also, I have identified what type of rock, is it Maram rock or black heart soil or sandy soil. Structures means what type of weak zones, joints due to earthquake, zones, all the things also identified. Groundwater tables we have identified. Now I will show you some maps we have prepared. So this is what is geomorphology map. You can see a lot of hilly area, rocky soil, and in some areas there sandy soils like that. This is the geomorphological map. This is Hussain Sagar. And most of the earthquakes occur near Durgama Cheruvu. Durgama Cheruvu is in Banjara Hills and Jubilee Hills area, Madhapur like that. So this is slope map we have prepared, right? This area is almost plain, but here Banjara Hills and Jubilee Hills area, lot of hill. This is a totally hilly region. This is contour map. Now this is the epicenter locations earlier happened, earthquake epicenters, mostly near Durgama Cheruvu. And for your kind information, there is a fault zone from Latur to Ongole in Andhra Pradesh, which is passing through this Durgama Cheruvu. And in our investigation, we have identified that fault, of course, NGRI Hyderabad And NRSA Hyderabad, they also confirmed our investigations, and they are now, in fact, placed in their records also. It's not dangerous, but there is a fault from Laturu to Ongole through this Durgama Cheruvu of Hyderabad. And these are all major cracks, minor cracks or major cracks. As I told, this is the fault continued from Laturu to Ongole. Right, now I come to the presentation of two structures I will take. One is normal structure, or I can say rigid structure, a building, right? A 7-story building, for example, 21 meters long and 12 meters width in plan, and each story height 3 meters, and type A structure, for example. Now it is idealized as the mass spring dashboard system, as I told you. Normally, this dynamic analysis can be idealized as mass spring dashboard system to simplify the analysis. Normally designers, they take it as a 7-degree freedom system because it has 7 masses, 7-story. But when I consider soil structure interaction and 2 springs, rocking and horizontal, it becomes 10-story. 10-degree freedom system. I will show you how I can convert it. So without soil structure interaction, it is 7-degree freedom system, and considering soil structure interaction, it is considering 9 degrees of freedom system, because I am adding 2 additional springs. So this is my plan. This is my plan, and this is my, of course, section elevation, 7 stories, right? This is a figure not considering soil SSI effect. And B structure, I am taking water tank. And in my lecture, I tell you the importance of elevated water tanks compared to the buildings. Very, very important, please. So an elevated water tank, 2.5 liter capacity is chosen for the analysis. And it is 7-meter diameter with supported by columns. And the height is 12.57 meters. And 3 bracings are provided against wind loads, and it is idealized as a 1-degree freedom system because one single mass is there without SSI effect. But when I consider soil structure interaction effect, I have introduced 2 springs, horizontal and rocking spring, then it becomes 3-degree freedom system. 3-degree freedom system. So I think all of you understood the nature of configuration of 2 structures. Building 7 not considering SSI effect, or 9 considering soil structure interaction effect. Water tank, 1-degree freedom system, not considering SSI effect, and 3-degree freedom system considering SSI effect. Now this is how we have to, this is very simplified example. All of you is the line diagram, 2.5 lakh water is placed at the top mass, right? And this is the staging, right? And the staging is divided into 3 bracings are there, because for wind we have to design bracings also. We should not make the columns very long, right? Therefore, now I can idealize as the 3 springs in vertical direction, and each between stories on stiffness, and this is mass. And all of you know, when I combine these springs, right? This is in all the columns in each story they are in parallel, in each story. Therefore, in parallel, I add the stiffness of the columns. Each column into number of columns. I will get K dash. Similarly, in this 2nd story, 3rd story, like that. But coming here, it is in series now. In series, when I add, when I make it the combined spring, 1 by K1 equal to 1 by K dash plus 1 by K dash plus 1 by K dash. That I think all of you know how to make equivalent spring constant. I will show you. Right. So for example, how to design against earthquake. I have taken M25 grade concrete water tank and M415 grade of steel. And all of you know how to calculate the Young's modulus of concrete. As per IS 456, 5000 root FCK. So I got 25,000 Newton per mm square. EC value, right? And I have converted into kilonewton per meter square. 25 into 10 to the power 6. Right? Where Kc is the stiffness, for example, each column. And you know how to calculate the stiffness of the column. That is I equal to BD cube by 12. Moment of inertia. So column size is 0.3 by 0.3 square column. Similarly, now Kc, stiffness of the column equal to 12 EI by L cube. Because we assume the top and bottom ends are fixed. So therefore, substituting these values, Young's modulus and length, all the things I got, stiffness value 2733 kilonewton per meter. Because when you substitute the notation also, you will get the stiffness in terms of kilonewton per meter. That means load per unit deflection stiffness. Now, what I have done, because they are in parallel in each between bracings, so I added 6 columns into stiffness of each column, 16,400 total each floor. But again, they are in series. When you say go vertically, they are in series. Therefore, total stiffness of the staging in series, I have to make 1 by K1 equal to 1 by Ks plus 1 by Ks plus 1 by Ks. So I got 1 by 16,400 plus 1 by 16, like that, 3 by 16,400. Therefore, I got finally the stiffness of the single degree freedom system is 5,467 kilonewton meter. In fact, this type of calculation is also available in the explanatory note of IS 1893 code. Now I have calculated the mass of the this also. How I have calculated, you can see. Weight of the water tank 2500 and weight of staging 500. And you have to consider only 50% of the staging to the mass, top mass, and the remaining 50% to the foundation. Therefore, I have added only 50% of 500. Therefore, 2500 plus 250, 2750 is the kilonewton is the mass. Sorry, weight, this is weight. But if I want to convert it to mass, you have to divide it by 9.81. All of you know that W equal to mg. Therefore, if I want to calculate mass, W by G, I got to approximately 280 kilonewton second square per meter. The unit of mass is kilonewton by mass, acceleration means second square per meter. Now, omega is root K by M, right? That is the natural frequency. And omega you get in radians per second. I got 4.42 radians per second. That means the natural frequency of that water tank I am considering is 4.42 radians per second. And when I convert it to cycles per second hazards, omega by 2 pi, right? Because 2 pi radians for each cycle. There are 0.7 cycle per second, right? Now using this omega and F, I can calculate time period also. 1 by F is the time period. Therefore, the time period of the fundamental time period, of course, is 1.43 seconds. Now, keeping this time period 1.43 seconds, I can go to IS 1893. For a particular time period, I can calculate the parameters also, from which I get shears and also the displacements. Now, this is the configuration. You can see this is water tank, for example. And when I consider soil structure interaction effect also, I consider rocking spring and also this horizontal spring. Damping also I considered. And this is the structure spring, as I told you, columns and all the things. And this is a top mass, water and all the things. This is soil mass. Therefore, now two masses are there. And also inertial effect is also there. Therefore, this I will go quickly. Now, what is the analysis now? Suppose earthquake load, this is FT, the external load, earthquake load, for example. And the left side is the resisting loads, and this is the acting load. What are the resisting loads? Inertia first, inertia of the structure. Every structure, every building or every structure will have its own inertia. Therefore, that is inertia force. And this is damping force, second. And this is the internal resisting force, K into X. right? Therefore, inertia force, damping force, and internal resisting force, they resist the external applied force. This is fundamental equation. Now I can put it in the matrix form. Inertia force, that means mass into acceleration. Is it not? Inertia force is mass into acceleration. And damping force, C into, that is damping factors, and this is velocity, right? And this is internal resisting force, stiffness Kx into displacement, right? So we have to formulate these equations. How to formulate these equations? Like this, put it in matrix form, mx double dot plus cx dot plus kx equal to axial force, right? And if you want to calculate the time periods or natural frequencies, you have to consider reactional force 0. That is the fundamental thing. Mx double dot plus kx equal to 0. You should not consider actional forces and damping forces also. Then only you will get the actual fundamental time periods and frequencies, natural periods. Right. Now coming to the soil structure interaction, what parameters you have to consider? Very, very important point. Response depends upon the soil properties now, like unit weight of the soil, then shear wave velocity, Poisson's ratio, shear modulus. These are very important parameters which changes the response parameters. Therefore, this phenomena is principally affected by the mechanism of energy transfer exchange between soil and structure. Transformation of energy between soil and structure, which is known as soil structure interaction. As I told you, soil is modeled as elastic cross-space theory, and soil structure interaction is modeled by introducing soil springs in horizontal rocking modes. Now, what I have to do now to calculate horizontal and rocking springs values? Therefore, I have to obtain the shear modulus of the soil. Therefore, how to get shear modulus of the soil? That is the density of the soil into Vs square. This is what is called shear wave velocity. How to get the shear wave velocity? There are some experiments, right? Cross-hole method like that. Therefore, already the values are available by so many others. I will show you the table also. Therefore, shear modulus can be obtained by this equation. And all of your Young's modulus equal to 2 into G into 1 minus Poisson's ratio. This everybody knows, right? And rho is the mass density, shear wave velocity, Young's modulus, Poisson's ratio. Now, what I have done, these are the different soils I have taken, types of soils in that study area. There are clay and soft silty clay type of soil, gravelly soils, fine sand, and loamy dense and medium sand, and moram, coarse sand, hard stone, sandstone quarters like that, fractured rock, granite stone. So I have taken almost 7 types of soils, and these are the shear wave velocities for those soils obtained from various others. And normally the shear wave velocity of loose soil is very low when compared to hard rock. Therefore, the stiffness of soil for hard granite is very high when compared to the stiffness of the loose soil. Right. Now, using this mass density and Poisson's ratio, I have obtained the shear modulus values like this. Then I have used these shear modulus values in my analysis. Right. Now, how to calculate now the spring constants? That is very important. Now, in fact, for isolated footings, right? Isolated footings, you can see Whitman and Richard has given some equations, and again he has given separately for isolated footings and circular footings, rectangular footings and circular footings. For normally for buildings we use the rectangular footing, but for water tanks, because it is circular in shape, we use the circular ring type footing. So different equations are also available. Similarly, even in case of pile foundations also, Novak has given some equations. So for piles also now the soil spring constants are available, right? So these are the, for example, equivalent stiffness values like this. So in this, I need Poisson's ratio, shear modulus, and beta values which can be obtained from this graph, and width of the foundation and length of the foundation, right? Similarly, in case of water tank, again this is Poisson's ratio, shear modulus, and this is the radius of the circular foundation. Horizontal stiffness, rocking stiffness, two values are given. Now, this is very important, how to formulate the matrix. All of you know how to idealize a 3-degree freedom system. So, this is M1, that is the top mass water tank, and this is the structure stiffness, columns stiffness. This is soil mass, M0 soil mass, rocking stiffness, and this is horizontal stiffness, 3-degree freedom system. Now, this is the free body diagram. This M1 is subjected to inertia force and stiffness force rocking. Therefore, the resisting force is stiffness into displacement, K1 into x1 minus x0 into minus theta h. As I told you, rocking, due to ground displacement, due to vertical displacement. And I1 theta double dot, I1 is the mass moment of inertia. Due to rotation, we have to consider mass moment of inertia. Also, I1 into theta double dot is the rotation acceleration. Therefore, for the above 3-degree freedom system, normally for 3-degree freedom system, you get 3 equations. For 2-degree freedom system, we get 3 equations. For 7-degree freedom system, we get 7 equations, from which you get the matrix form. So, like that, I got 3 equations. So, from mass 1, I got M1, I considered the total forces on mass 1, that is inertia force, stiffness, equal to 0. Similarly, for soil mass, again, soil stiffness and displacement, second equation. And for rotation, that is I1 theta double dot, I like that. So 3 equations, and these 3 equations are put in matrix form. You can see mass matrix, and this is the acceleration vector. Mass into acceleration. This is the Kx, stiffness matrix, and this is displacement vector. So like that. So mass matrix is M1, M2, and this is I is mass moment of inertia by h square. Why I have made divided by h square? Because in matrix my units must be same. Right? I will explain that part also. Coming to the stiffness matrix. So from the equations, I formulated both mass and stiffness matrices. Now here, mass unit is kilonewton second square per meter. I told you. Because weight by acceleration, kilonewton by meters per second square. We get kilonewton second square per meter. And unit of mass is I value kilonewton meter second square. Therefore, what I have done, I converted I into mass unit. Right? Therefore, divide by h square. If you divide it by h square, I get the same unit of mass. Therefore, all the parameters of this matrix should be in one unit only. Right? Similarly, here also K1 and K2 by h. So this is the mathematical model of, you can see now, when I don't consider SSI effect is 7-degree freedom system and water tank single-degree freedom system. Look here. And when I consider SSI effect 7 plus 2, 9-degree freedom system, and water tank 3-degree freedom system, because I introduced 2 springs. And this is mathematical model and 3-body diagram. As I told you, so when I don't consider SSI effect, only 7x7 matrix, up to red mark only. When I consider SSI effect, 9x9 matrix, right? M0 and I by h square soil masses. And M1, M2, M3, these are all structure masses. Same thing in case of stiffness also. When I don't consider SSI effect, it is 7x7 matrix. When I consider stiffness of soils also, it is 9x9 matrix. Now, as I told you, I take this diagram given in IS 1893, and when I know the time period, then I get the SA by G values, from which I get the shears as well as displacements. That is the analysis part. Therefore, using the free vibration analysis and the natural frequencies and using the mode superposition method or any method, as a matter of fact, as given in IS 1893, The story displacements you can obtain, the base shears up to you can obtain, the story displacement, shears also you can obtain. Now these are the results I got. So interestingly, the horizontal stiffness is very high in case of water tank when compared to building. The reason is, even though the soil is same, because the structure is flexible. Please, all of you, please listen this point very carefully. Therefore, the stiffness of the structure also play vital role. The mass of the structure will also play vital role when you consider soil structure interaction. And coming to the shear wave velocity, rocking stiffness, this is horizontal stiffness. Same thing, rocking stiffness. Coming to rocking, very interestingly, building stiffness is high when compared to the water tank. Reverse side. The reason is the mass of the water tank is very high at floor level. And this is the, in fact, the graph given, that is shear wave velocity versus the natural period. Similarly, this is time period. I go quickly. Coming to displacement, the displacement of water tank, I'm sorry, Reddy is water tank, is more than compared to the 7-story structure. All of you please listen me carefully. Why the displacements are very high in case of water tank? Because the top mass is very heavy and slender structure. Therefore, the displacements are very high in case of water tank when compared to a 7-story building. So that's why water tanks are typical structures, and they need to be designed against earthquake or lateral loads also. And even story displacement for different stories also we have obtained. So these are all different graphs we have obtained for shears as well as the displacements, which are very important parameters for design. These are the 4 conclusions finally on my thesis work. Important conclusions are: the time period of both structures invariably decrease with the increase of soil stiffness, right? Therefore, for flexible soils, the time period will increase. When time period increases, what will happen? Your shears and displacements will increase. Therefore, generally it is seen that the displacement values will increase with the decrease of soil stiffness. So therefore, loose soils, they give a lot of displacements. Therefore, now all of it, the third displacement is very important. Though the height of type B structure, that is water tank, is less compared to type A structure, the displacement of type B structure are found to be greater than type A structure. This can be attributed due to the configuration of the elevated water tank with the top heavy mass and slender columns in the staging. Hence, stiffness of columns for such structure shall be increased. This is very important. If we want to design any elevated water tank against lateral loads, you take care of the stiffness of the columns. Bracings are important. You have to provide more bracings, not only in vertical direction, but also horizontally also. So it is also observed that there is a wide variation in the decrease of displacement from loose soil to hard rock, as I told you. So that's why IS code also says that in case of hard rock, you can neglect SSI effect. But in case of loose soils and earthquakes, you have to consider soil structure interaction effect also. And soil damping is also very important. So the final conclusion on influence of soil structure interaction, I have already explained most of these parts. Right? So in spite of many scientific and technological advancements during past 100 years, a threat of natural disasters, particularly earthquakes, tsunamis, and in our coastal regions, they remain untamed. History and geological evidences and experiences show that the rate of occurrence of these natural hazards will increase in future. Dear participants, please note down this point. In the future, we have to face so many cyclones, so many natural hazards. Earthquake-prone society has to learn to live in earthquake, and we have to live in earthquakes only. And the society should be made more safe against earthquake damage, and construction of earthquake resistant structures is the answer. Megacity is due to sheer size, complexity, very close buildings, very high-rise buildings being situated in high seismic regions are highly vulnerable to future coming earthquakes. Hence, urban areas require special consideration during evaluation of risk disasters. Of course, there are some, these are all, you can see water tank is fallen because of, they have not considered soil structure interaction, like that. Okay, sir, thank you very much for giving an opportunity. And I trust to some extent, I have given you something to the participants. What I have done, that only I could able to transform my knowledge. And if you have any queries or doubts, most welcome, please.
Thank you, sir. Thank you very much for your elaborate lecture on soil structure interaction, which is a most important topic for all structural engineers. You have highlighted the important parameters which are to be considered while designing the structures. It is very important, sir. We are highly thankful for sharing your knowledge. At this age also, you are very energetic, and we have to learn so many things from you, sir. And
Thank you.
we are highly thankful to you, sir. In this conclusion, because of this earthquake effect consideration and all these things, I request all structural engineers to consider not to go for float columns as far as possible. Nowadays, as per new code, float columns are not permitted in the code also, and cantilevers are to be reduced or to be avoided as far as possible, so that the structure safety will be increased. Try to avoid odd-shaped structures to have more structural stability. And another important aspect is ductility aspects are to be considered. And the soft story effect is most important in case of stilt floors and cellar floors, and the structural engineers and the geotech engineers should be cautious about this soft story effect while designing the structures. And this clay, soft and silty clay will have very low shear wave velocity. Hence, while designing the structures, this aspect is to be considered carefully. Thank you very much, sir. With all your detailed lecture, our knowledge is enhanced in this aspect, and we are highly thankful to you, sir. And now I request the participants to express their queries or doubts about this topic.
Good afternoon, sir. I am Professor Ravindra, JNTU Kakinada.
Thank you, sir. Thank you.
Reddy garu.
Thank you, sir.
So,
Yes, sir.
Reddy garu, this is Ravindra from JNTU Kakinada.
Sir, Dr. Ravindra is our ACC MC member, sir.
Am I audible, sir? Ravindra, sir.
Sir, good afternoon.
Sir, good afternoon, sir. Good afternoon.
How are you? How are you?
Fine, sir. Fine, sir. Fine.
I think we meet nowadays in online mode more frequently than I think it's almost a year after that we have met.
Yes, sir. Yes, sir.
How are you, sir?
I'm very much thankful to you for giving more sessions, sir, during my thesis time also. I'm very much thankful to you, sir.
So soon as I could not follow your presentation from starting, sir.
Okay.
Soil structure interaction is a huge problem for discussion. Am I audible, sir?
Yes, sir. Yes, sir.
Yeah, huge problem for interaction, and moreover, I'm teaching earthquake resistant design right now after the first course on structural dynamics. Some of the pertinent points, we especially small 3G+3, G+4 structures, things are okay. But as you go high, and also we take up more complex structures, and your irregularities, structural irregularities, shape irregularities, soft stories, all these things need to be properly brought into design aspects. So most of the designs that we do are monotonous in nature. And the water tank concept, especially there is a possibility that we'll have it as an eccentric mass. So these are all developing torsional system. And really, your presentation is really good. And of course, I'm very much sure some of the concepts that you have discussed require students to have a little bit of dynamics fundamentals. So nice of you, sir. You could spare very valuable time with us here. Since last 3 weeks, I have been conducting research methodologies program for my PhD students. About 300 and odd PhD students at 2019 were taking this course. So nice. In fact, I missed the starting portion. The topic that you have chosen, soil structure interaction, is one of the basic requirement of nowadays structural engineers. We cannot anyway. The moment we are going beyond 4 or 5 floors, we cannot avoid soil mechanics concepts, especially information related to foundation system. And interact system is never put into design nowadays. The topic that you have discussed, both of us act independently, both soils and structures people. We take bearing capacity there, and so we'll start our issue from there. And the topic that you have discussed is very good, sir. And perhaps I think we need to give a session with more basic things here. Not only from do's and don'ts point of view. From right now, the calculations that you have shown are really good. Your matrix, and also the way you need to take higher floors into consideration. Thank you so much, sir. It's a nice listening to you. We'll get in touch with you, sir. Thank you so much.
Thank you, sir. I forward my PPT to you, sir.
Thank you, Ravindra Garu, for your participation and few words about Dr. Reddy. Thank you, sir.
That is very active at the age of 70. I see him almost every board.
Yes, sir.
I go and almost every board of studies in many universities and also government and other agencies. We were in Krishna University panel. We were in many other prominent panels as team members here. And he had a flair of going for hand calculations.
Sir.
Very popular, and he is a grand old man in civil engineering. We can learn a lot with his expertise. Some of the equipment that I have been handling, his source is taken from Goodlevel Engineering College, where he is presently working right now.
Yes.
Last week also I am there in SRKR, sir, for research center inspection.
Yes, sir.
Yeah. Thank you, sir. Thanks a lot. We'll be in touch with you. Namaste.
Dr. Harikrishna, am I audible? Dr. Harikrishna.
Yes, sir. You are audible, sir.
I am very glad that. How are you, Harikrishna?
Yeah, fine, sir. I am very fine. Hope you are also.
Dr. Harikrishna, to the participants, Dr. Harikrishna, he is a very expert in wind analysis, and he went to Australia, and now he is heading the wind expert SCRC Chennai, Tamil Nadu State. SCRC.
Yes, sir.
Thank you very much, Harikrishna. Thank you very much.
Sir, glad to meet you, sir. Glad to meet you, sir, Dr. Harikrishna Garu.
Yes, sir.
Thank you very much for your participation, sir.
Yes, sir. Sorry is our teacher.
Yes, sir.
We are very happy to again become student and his lecture.
Sir.
It's a privilege for us.
Thank you. Thank you, sir.
Thank you.
Sir, any questions? In the meantime, I am going through the chat box, sir.
Excuse me.
I just, any questions?
Sir.
Yeah.
Sir, very good afternoon, sir. Dr. Reddy Garu.
Good afternoon.
Sir, this is Chandrasekhar from Kakinada.
Okay.
Your lecture is very useful and informative, and throwing light on the necessary precautions to be taken while designing earthquake resistant structures. And what is happening most commonly in and around tier 3 cities like us, Kakinada or something else, is general feature is the stilt or cellar floor in the every apartments. Almost all are stilt plus 5-story buildings. Now coming to the earthquake zones, these are inevitable and we cannot avoid it. For the reason, very reason, the approvals and permissions are such. The stilt floor is allowed to utilize for parking purpose only, and only one watchman room will be built. Most of the cases, 90% of the buildings are such. What to take care in designing such type of buildings to make them earthquake resistant?
Very good question, sir. Very good question. In fact, as I told you initially, the soft story buildings will be displaced more when compared to the general building.
Yes.
Therefore, in such a case, what you have to do is first you have to make the structure ductile in nature. That is number one.
Pardon, sir?
Make the structure ductile.
Ductile, yes.
Ductile. That means IS 13920 code you have to use. IS 13920. And the next thing is, you can, without affecting the car parking, you can connect two columns with the bracing or shear walls without affecting car parking. That means parallel to the car parking, you can connect two columns with the shear wall or bracing system.
Sir, most unfortunately, the designs are becoming complex and critical, but to satisfy the car parking, because based on the utilization of TDR and all, we are building more floors than permitted. Means with the utilization of TDR.
And one more thing, sir. One more thing is,
Sir.
since stiffness is very important factor, stiffness,
Yes.
You can increase slightly the cellar columns. Cellar column size you can increase, and other floors you can decrease. That is so that the displacement of cellar floor can be minimized.
And normally we are doing that, sir, because in cellar the column sizes are more, and from first floor onwards to match the aesthetic sense and to be flushed with the wall thickness, we are reducing the column sizes.
Yes, sir. And another thing is, all the columns should be properly connected by plinth beams.
Yes.
Some designers are not following this rule. Suppose the foundation, excuse me, suppose they are using pile foundation or the isolated footings at a deeper depth, right? Sometimes cellar floors may be there. In such a case, you have to provide two plinth beams at two different levels. They are not doing like that. Only at ground floor, they are putting plinth beam, but at low level also, you have to connect all the footings. Therefore, suppose when the pile foundation is, isolated footing is at a depth of 3 meters, you have to connect all the footings with plinth beam at that level and another plinth beam at basement level.
Yes.
This is very important.
Thank you so much.
Hello, sir. Hello. Hello.
Yes, sir. Yes, sir. Please, sir.
Sundar, sir, I have one question.
Yes,
Sir.
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 Yes, please. Yes, please.
I am Dr. Narasimha, sir, from Kakinada, Akriti Consultants, Kakinada, sir. Sir, I have one question is regarding the soil structure interaction, sir. Whenever we are going for the seismic resistant designs, the geotechnical investigation report generally don't addressing the liquefaction potential of the soil and also the dynamic bearing capacity of the soil. Also, in the case of any retaining wall structures, it is also necessary to have the dynamic lateral approaches that is to be considered while designing any retaining structures is to be considered. What is your opinion on that, sir? Regarding is it the fundamental necessity is there to consider the liquefaction potential and also the soil dynamic bearing capacity in the geotechnical investigation report?
Yes, sir. Very good question you have posed, in fact. And, this idea was already in the minds of the central government design office also. When I attended a webinar 1 year back, this question was posed then also. He actually said particularly when you are going to construct an important structure in seismic region, the soil engineer has to provide not only the soil data, but also the dynamic data also, as you said. What is the shear modulus, what is the shear wave velocity at that region, and also the other parameters required, soil parameters required for the design. And it was already in the minds of the engineers. So as you said, at least now it's, they have to provide this condition also while collecting the soil reports. This is a very good question.
Thank you, sir.
Sir, there are some questions and representations in this chat box, sir.
Yeah, sir.
Yeah, one is IS 1893 Part 1, 2016 and not 2015. Here as mentioned in last slide. Maybe typographical error, sir.
Right,
Okay.
right. 2015 is correct.
2015 is correct. Sir. Next is
Sorry, 16 is correct.
16 is correct. Yes, sir. 16 is correct, sir. It's a typographical mistake. It will be rectified, sir.
Okay.
And this is from Engineer Babu Mahesh to everyone. Excellent presentation by Dr. SRK Reddy Garu. He is my project guide during my BE from SRKR Bhimavaram. Thank you ACC Kakinada chapter to invite such valuable speakers and organize relevant topics to practicing engineers. Thank you very much, Babu Mahesh Garu. And another is from him only. Request to brief about soil cement technique. Where should we adopt this technique?
In fact, soil cement technique, it comes under stabilization of soil, sir.
Yes, sir.
Stabilization of soil. Suppose the bearing capacity is very low, then in fact soil limes, like earlier also, there were so many types of soil stabilization techniques. So this soil cement technique can be used to increase the not only bearing capacity but also the shear capacity.
Yes, sir. We'll have one separate session on this topic of soil stabilization, different methods of soil stabilization. We'll have one separate webinar, sir, Babu Mahesh Garu. And another question from him is request to brief about, okay, that is over. And how to get rid of liquefaction.
Yes. This liquefaction is a very, very important factor because particularly during earthquake, what will happen, these water table levels, they come up.
Yeah.
And particularly in the case of soil, sandy soils, what will happen, when the water enters to the sandy soil, the shear stress becomes zero. Therefore, particularly in the case of liquefied soils, we have to take care while designing the structures. That means we have to provide some sort of stone columns stabilization of such soils. Liquefaction effect is very dangerous parameter, particularly in the case of earthquake prone regions. It is a separate topic to be dealt with.
Yes, sir. Yes, sir. Is it possible to avoid liquefaction of soils in terms of loose problematic soils and stiff soils? If any, please brief about such case studies. Sir, it is a very big topic and it requires at least 2 to 3 interactions. We'll make it as a separate topic, sir.
Yes, sir. It is a separate topic.
Yes, sir. Yes, sir. Yes, sir. From Ravindra Kadareswari. Thanks a lot for very nice concept clarifications. Chartered engineer from Chhattisgarh. Thank you very much, sir, for such an informative session. Engineer Ravindra Kashwani. Thank you very much for such an informative session. Thank you very much, so much for the session by K.S. Jaideep. Thank you, Professor SRK Reddy Garu, for a holistic presentation on SSI with examples and case studies. Thank you, sir. Thank the organizers for arranging the seminar by Dr. Ramakrishna Garu. Syed K. Khaja Mia, thank you, sir. Thanks for lecture, sir, from Durga Prasad Garu. Thank you for enlightening lecture, sir. Many thanks to organizers for arranging such a great lecture. Sir, from Bhaskar Pindra. Yes, sir. Yes, sir. Yes, sir. You can, sir.
Yes, sir. One more question is that I want to clarify, sir.
Yes, sir.
Sir, Dr. Reddy garu, sir, I have one more question, sir.
Welcome, please, welcome.
Right, sir. Thank you, sir. Sir, regarding for the shear wave velocity, for some of these site-specific designs, we are doing the shear wave velocity as a geotechnical investigation point of view, sir.
Right.
Suppose we did it on a micro generation for a given city, like what we are doing for the seismic generation. Is it will be any helpful for the current context of your presentation, sir?
Definitely. In fact, your question is rightly pointed out. Nowadays, seismic zonation map is very much required cities and also towns in seismic regions. Now, Delhi people are doing, Mumbai people are doing, they are doing micro zonation map. And during this micro zonation activity, we will be getting all these parameters. As you said, the shear wave velocity, shear modulus, type of soil, and natural slope, everything, type of rock and all the things. Therefore, microgenation activity is very important. Smart cities now. Now in AP state, 3 cities were declared as smart cities: Visakhapatnam, Kakinada, and Tirupati. So these 2 cities need to be surveyed with microgenation only. Then everything can be identified for designing not only structures, for drainage systems and other things also. It's a very, very good question you have posed.
Right, sir. Thank you, sir.
Thank you, Dr. Rao garu. Next is from KS Jaideep. How to consider displacement obtained at ground level when SSI is performed?
Yes, that is, as I told you, while idealizing the system, you remove the structure and only apply the soil springs. Then you will get the displacement of the ground only. I have already displayed that figure in my lecture. That, the displacement due to earthquake, that is ground displacement without structure. Then with structure, we will get the displacement due to horizontal spring, rocking spring, and also the structure spring. Therefore, without this structure also, you can get the displacements at a particular point if you have the soil parameters.
Thank you, sir. Thank you. And next is from Praveen. Can you share us the link for lecture if recorded? I missed that initial part of the lecture. Sir, it is in the YouTube. ACCEI Kakinada Center has a YouTube channel. There it is, the recorded session will be available, sir. You can go through that. Not only this, all the webinars which were conducted till now are in that YouTube channel, sir. Please refer, sir. Thank you.
Sir,
Sir.
if you permit me, I have one more question, sir.
Yeah, please.
Right, sir. Sir, I have one more question, sir. Regarding that, you are saying that soil stiffness is also to be taken into account while dealing with the modeling. Yeah.
Right.
In that case, shall we have to couple the spring stiffnesses matrix with the structural stiffness matrix, sir?
That's what I have explained. Structure stiffness has to be coupled with soil springs also. That's why if the structure is having some degree, for example, if it is a 3-story building, 3-degree freedom system, then we have to add another 2 soil springs. It becomes 5-degree freedom system, and you get 5x5 matrix, mass matrix and stiffness matrix.
That is the number of degrees of freedom by number of degrees of freedom.
Yes, the number of degrees will increase. You can suppose your structure is eccentric, for example, P-shape, then you have to consider torsional spring also. And empirical formulas are also available for torsional spring, vertical spring, horizontal spring, and rocking spring.
I think Professor Shamshed Prakash sir work is there.
Right. Very good. Shamshed Prakash and also Ravak. They have presented so many papers in this aspect.
Yes.
Right.
Thank you, sir.
Thank you, Dr. Rao garu. And Matta Venkata Surinarayana says that one more smart city is there in Andhra Pradesh. That is Amaravati, the capital city of AP. Okay, sir. Any questions, sir?
Sir, this is Harikrishna. It is not a question. Sir, you are showing one image or photograph of a bridge pier which got damaged due to variation in soil characteristics in a small zone itself. Now, if we take a power plant structure like a natural dot cooling tower, which base is hundreds of meters, about 100-meter diameter it will be. So in such case, the soil characteristics variation at the site, we can expect it to vary spatially. In such case, I feel SSI becomes very important in such kind of structures where even a small geometric imperfection can cause very adverse implications on the structural safety. Have you come across any criticality with respect to such kind of structures?
Yes, Harikrishna. In fact, as I told you in my lecture, very stiff structures will definitely have a lot of damage due to soil effect also, as you said. Particularly when a chimney or a tower structure like that, when it stands on loose soils, so during horizontal loads, that is earthquake or tsunamis, a lot of changes will occur in displacement as well as the shears. Whenever any stiff structure is we are going to design or construct, we have to consider the soil structure effect also. That means the foundation, the type of foundation and the extent of foundation is also very important for such type of structures.
Yes, sir. Thank you, sir.
And rigid structures are more prone to failure during earthquakes, rigid structures. That's why ductility is very important. Even in case of chimneys, while connecting the members, if you provide that ductile in nature, ductility effect is good in the design. It is better.
Thank you, sir.
Thank you, sir. And now, once again, Babu Mahesh has posted to continue with the question by SVM Garu. Soft storage structures have been retrofitted by bracing with steel without disturbing car parking. It is
Yes.
adopted in US. It is limited up to 3 to 4 storied structures.
Yes, sir. That's what I told you.
Yes, sir. Yes, sir. Yes, sir.
Shear wall connection is very, very important. Shear wall
Yes,
connection.
yes, sir. For already existing structures, this retrofitting is to be done.
Yes.
But the topic is that while designing the new structures, you have to consider the soft story concept while designing the structure. That is important, and all structural engineers must be careful about this earthquake design aspect. Most of engineers, what they are doing is they feel that they are economizing the structures, but that is not economizing the structures. They are making cheap structures, which is a very costly affair to retrofit them at a later stage. To avoid such things, what we request the engineers is to consider the parameters which are very much specified in ISO 1893 Part 1 2016 and follow make the designs with detailing as per IS 13920 so that the structures will be safe, economical and long lasting. Thank you, sir. And any more questions?
Thank you, Mahesh.
P. Venugopal Rao. what precautions to be considered for design of unsymmetrical structures for soft story?
Yes, again, IS 1893 has given unsymmetrical, that means, for example, mass unsymmetry, stiffness unsymmetry. Therefore, while calculating stiffness and also masses, we have to consider the eccentricity factor also. Then that should be incorporated in the analysis. Otherwise, what will happen? Movements will be increased. Therefore, IS 1893 has given specifically regarding that point, sir. Irregular structures and unsymmetrical structures.
Thank you, sir. And once again, P. Venugopal Rao, what precautions to be considered for designing unsymmetrical structure? Okay, it is repeated. Thank you, sir. Any more questions? Can I conclude? Can I close the session, sir? Any more questions? Thank you, all participants, and I profoundly thank. Yeah. Dr. Ramakrishna Reddy garu for his elaborate lecture on this most interesting topic, and this is the second lecture we had from him. We are highly thankful to him for his detailed presentation in a very lucid language, and it is highly adaptable and reachable to all engineers, and we are highly thankful, sir. I thank all the participants for spending their Sunday with us for this knowledge sharing session. Our Kakinada Center has continuously making efforts to make the engineers more strong technically, and with state of art technology and the developments in civil engineering, because almost all engineers have completed their studies long back, and there is a gap in learning. To avoid that gap, we planned every month one webinar, and with the latest topics, and to which will enhance the knowledge levels of our engineers, so that the country will get benefited. With that effort, we are making these webinars very regularly, and I request all participants to continue their patronage for our webinars. Thank you very much.
Thank you, sir. Thank you so much.
Thank you.
Thank you, Sundarrao garu, for the nice efforts.
Sundarrao garu,